Welcome to our channel. In this video, you will learn about the law of cosines and how it is used to solve some cases of oblique triangles. Now, let's derive the formula of law of cosines. Consider the acute triangle ACB and obtuse triangle ACB. Their sides will be represented by small letters. We have to cut them out into right triangles. We draw an altitude that starts from the vertex of the angle C, and it goes to its opposite side. The altitude's endpoint will be represented by capital letter D. The altitude, considered as the side of the created right triangle, will be the side H. The opposite side of the angle C is the side C. Side C is now cut into two parts. These are the line segment AD and the line segment BD. The line segment AD will be the side M. The line segment BD is equal to the difference between the value of side C and the value of side M. Therefore, in right triangle BDC, line segment BD will be the side C minus M. On the other hand, we draw an altitude that starts from the vertex of the angle C. The altitude that runs vertically downward should be perpendicular to the base of the obtuse triangle. From the endpoint D of the altitude, we draw another line that runs horizontally, and it goes to the vertex of the angle A. Now we have created right triangle ADC. The line segment DA here will be the side M. The altitude will be the side H. The result of the sum of the obtuse triangle ACB and the right triangle ADC is the right triangle BDC. Side M is the extended part of the side C. Therefore, the opposite side of angle C in the right triangle BDC is the side C plus M. Now let's begin analyzing right triangle BDC of the acute triangle ACB. To find the missing value of a side of a certain right triangle, we apply the concept of Pythagorean theorem. In right triangle BDC, side A has the longest side, and we consider it the hypotenuse. Side H and side C minus M are the shorter legs. Replacing these letters from the equation of C squared is equal to A squared plus B squared, now we have the equation of A squared is equal to H squared plus the quantity of C minus M squared. Simplify the equation. Now we have A squared is equal to H squared plus C squared minus 2 times C times M plus M squared. Let's move on to the right triangle BDC of obtuse triangle ACB. Side A is the longest side of the right triangle BDC. Its shorter legs are the side H and the side M plus C. Apply the concept of Pythagorean theorem and replace the letters from its equation. Now we have A squared is equal to H squared plus the quantity of C plus M squared. Simplify the equation. It gives us A squared is equal to H squared plus C squared plus 2 times C times M plus M squared. Considering the right triangle ADC of the acute triangle and right triangle ADC of the obtuse triangle, these two right triangles have side A, considering the longest side. Their side H and side M are the shorter legs. After applying the concept of Pythagorean theorem, these two right triangles have the same equation of B squared is equal to H squared plus M squared. H squared and M squared are visible in the equation of right triangle BDC of the acute triangle and obtuse triangle. Then therefore, we have to replace it with B squared. Here's the equation from right triangle BDC of acute triangle ACB. A squared is equal to H squared plus C squared minus 2 times C times M plus M squared. Arrange it and replace H squared plus M squared by B squared. Now we have A squared is equal to B squared minus 2 times C times M plus C squared. Here's the equation from right triangle BDC of obtuse triangle ACB. A squared is equal to H squared plus C squared plus 2 times C times M plus M squared. Arrange and replace H squared plus M squared by B squared. Now we have A squared is equal to b squared plus 2 times c times m plus c squared. To find the value of m, we have to get the cosine function of angle A. The cosine of angle A of the right triangle ADC in the acute triangle ACB. Cosine A is equal to the value of the adjacent side, all over the hypotenuse. Now we have cosine A is equal to m, all over b. Multiply both sides of the equation by b. And it gives us b times cosine A is equal to m. The cosine of angle A of the right triangle ADC in the obtuse triangle ACB. Cosine A is equal to the value of the adjacent side, all over the hypotenuse. We have cosine A is equal to m, all over b. Analyzing the angle A of the obtuse triangle ACB, it consists of two angles with same vertex. Adding them is equal to 180 degrees. To get the value of the angle A of the right triangle ADC, we have to subtract 180 degrees to the value of the angle A. So, our new equation is cosine 180 degrees minus A is equal to m, all over b. Multiply b to both sides of the equation. Now we have negative b times cosine A is equal to m. Substitute the value of m to the equations. Here is the equation from the acute triangle ACB. A squared is equal to b squared minus 2 times c times m plus c squared. Replace with the value of m with b times cosine A. And the result is a squared is equal to b squared plus c squared minus 2 times c times b times cosine A. Here is the equation from the obtuse triangle ACB. A squared is equal to b squared plus 2 times c times m plus c squared. Replace the value of m with negative b times cosine A. And now here it is. A squared is equal to b squared plus c squared minus 2 times c times b times cosine A. As you can see, the formula that we created from the acute triangle and from obtuse triangle are exactly the same. If we are going to replace all the letters and do the same process of calculations, we will arrive having these formulas. A squared is equal to b squared plus c squared minus 2 times c times b times cosine A. B squared is equal to a squared plus c squared minus 2 times a times c times cosine b. C squared is equal to a squared plus b squared minus 2 times a times b times cosine c. These are the cases in oblique triangles that should be solved. Oblique triangle has two sides and an angle that is not opposite of one of them. Oblique triangle has only three sides given. Case 3. Oblique triangle has two sides and an angle that is not opposite in one of them. Let's say, for example, the value of side A is equal to 5. Side C is equal to 6. Angle B is equal to 60 degrees. Find the value of the side B. We can use the formula of b squared is equal to a squared plus c squared minus 2 times a times c times cosine b. Substitute the given values to the formula. We have b squared is equal to 5 squared plus 6 squared minus 2 times 5 times 6 times cosine 60 degrees. Simplify the equation. It gives us b squared is equal to 61 minus 30. Subtract 61 and 30. Now we have b squared is equal to 31. Get the square root of both sides of the equation, giving us the result of b is equal to 5.568. We can solve the remaining missing values using the formulas of law of sines. Case 4. Oblique triangle has only three sides given. Let's say that the value of side A is equal to 5, the value of side C is 6, and the value of side B is equal to 5.568. Find the value of the angle B. We use the formula b squared is equal to a squared plus c squared minus 2 times a times c times cosine b. Plug in all the given values to the formula. Simplify the equation. Transpose positive 25 and positive 36 to the left-hand side of the equation. Positive sign will be changed into negative. Now we have negative 25 minus 36 plus 31 is equal to negative 60 times cosine b. Simplify the equation. It gives us negative 30 is equal to negative 60 times cosine b. Divide both sides of the equation by negative 60. Now we have 0.5 is equal to cosine b. To convert this into degrees, we have to use the inverse cosine function. Now the inverse cosine of 0.5 is equal to 60 degrees. We can solve the remaining missing values using the formulas of law of sines. That's all for today. Please like, share, and subscribe. The YT University.